Hello, my dear friends and dear learners. Welcome to my YouTube channel. I'm Vinay BK, Assistant Professor, Department of Electrical and Electronics Engineering, University of Technology, Virgil. In this video, I'm going to explain about DC motor, back EMF, and significance of back EMF. So, before going to start with this uh, very important concept about DC motor, let us know some basics. You all know the definition of generator and motor. Generator nothing but it converts mechanical to electrical, and motor is nothing but convert electrical to mechanical. And also explained about working principle of DC motor in my previous video. So I'll just tell you the statement which states that when a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. So in this video, I'm going to explain about a back EMF and significance of back EMF. So what is back EMF? When the armature of DC motor rotates under the influence of the driving torque, the armature conductors move through the magnetic field and hence EMF is induced in them. As in a generator, the induced EMF acts in opposite direction to the applied voltage V. This is according to Lenz's law. Hence, it is known as back EMF, or you can say it as counter EMF. It is represented by E suffix B. That is, EB is given by phi Z NP by 60A. This is the same as the generated EMF equation of generator. So here the equation to find out the back EMF in DC motor is given by phi Z NP by 60A. And remember one thing, that the back EMF, that is EB, which is always less than the applied voltage V, although this difference is small when the motor is running under normal conditions. And already I explained about working principle of DC motor, how a back EMF occurs in DC motor. Consider here a back EMF which produces. So the question is that how it produces. As explained in the working principle, whenever current carrying conductor placed in a magnetic field, it produces a driving torque. So once the driving torque which produces, the rotor starts to rotate. So due to that rotation, it induced EMF in armature. It induced EMF in armature. Hence the direction of induced EMF, which is opposite to the direction of applied voltage. You can see here the direction of induced voltage, which is opposite to the direction of applied voltage according to Lenz's law. Whereas V is nothing but input voltage, or let's say supply voltage. Whenever the supply is given, DC supply is given to the armature, the current starts to flow to the armature, nothing but IA. So this is a direction of current which flows from supply towards armature, whereas the armature is having the internal circuit diagram of EB and RA in series. So let us know the voltage equations of back EMF. So the voltage equations how we are getting is nothing but very simple. Just by applying KVL, you can get voltage equation. For example, I'll be taking the loop in clockwise direction. I'll just mark the second polarities. So here it is, the direction of current is downward. So that here nothing but this is a plus and this is minus. So that minus V plus IARA, then plus EB plus V brush equals to 0. So by simplifying that, we can get voltage equation as V equals to EB plus IARA plus brushed contact voltage drop. So it's a small and you can neglect the brush voltage drop so that I can get the armature current in a DC motor as V minus EB divided by RA. Here the voltage of back EMF, sorry, sorry for the, here the back EMF EB is always less than applied voltage V. Okay, so now let us discuss about significance of back EMF. So before going to know about the significance of back EMF, so here I can take an example as a bike. Here they'll be having two cases. One, the first case is when a load increases and when the load decreases. Okay, so when a load suddenly put on the motor, the speed is going to reduces. So I'll be just giving you a practical example how it reduces. For example, if you're taking it as a bike, so the speed of the bike, whenever you'll be riding a bike in a high speed, to reduce the speed of a bike, we are going to apply brake. So in this case, the brake which will be act as load, whereas the speed of the bike which is represented by n. So it is nothing but whenever a brake which applied suddenly, the speed of the bike is also reduces. So that when the load suddenly put on the motor, speed is going to reduces. When the speed is reduces, back EMF is directly proportional to the speed, so that back EMF is also reduces. When the speed reduces, the back EMF is also reduces, so that due to which EB is going to reduces. Once the back EMF is reduces, if the back EMF is reduces, V minus EB drop is increases, so that V minus EB increases. If V minus EB is increases, this is directly proportional to armature current, so that the motor draws high armature current, so that motor draws more armature current, due to which IA is also going to increases. If armature current increases, if armature current increases, due to which force is also increases, and also the force which is directly proportional to armature torque, which is directly proportional to armature current, so that the force is also increases, due to that torque is also increases, that is armature torque is also going to increases. It is denoted by T suffix A. So which means that a conclusion, I'm going to give a conclusion: when the load suddenly put on the motor, the increase in torque is just sufficient to satisfy increased load demand. Increased load demand. So let us know how the torque is just sufficient to satisfy increased load demand. So initially when the load suddenly put on the motor, speed is going to reduces, so due to that eb is reduces. I hope you are looking at the arrow mark. So if the eb is reduces, v minus eb drop is increases, due to that ia is going to increases. If ia increases, the force is also increases, so due to that armature torque is also increases, which means that the increase in torque is just sufficient to satisfy increased load demand. Suppose when the load suddenly decreases, which means that suppose the applied brake, if you're going to release the brake applied to the bike, the speed is going to increase. So that when the load on the motor is decreased, speed tries to increase. If the speed is going to increases, back EMF is also increases. If the back EMF increases, this cause V minus EB drops to reduce, which reduces the armature current. If the armature current reduces, the motor speed stops increasing when the armature current IA is just enough to produce less torque required by the new load. So that back EMF regulates flow of armature current, and it automatically alters the armature current to meet the load requirements. There are two cases: when the load increases, speed decreases, back EMF decreases, V minus B is also increases due to that current IA is increases, so that torque is increased just to satisfy the load demand. Suppose if the load decreases, speed is going to increases. If the speed increases, back EMF increases. This causes to reduce armature current, which means that the motor is the motor speed stops increasing. That is, the motor speed decreases when the armature current IA is just enough to produce the less torque to required by the new load. So the final touch, the conclusion here: the back EMF which regulates the flow of armature current, and it automatically alters the armature current to meet the load requirement. So this is about the significance of back EMF of DC motor. Thank you, my dear friends. Thanks for watching. If you are satisfied with the video, please do like and subscribe to my YouTube channel. Thank you one and all. Have a good day.